We'll proceed directly with the CNSC's presentation, but before we do, apparently NRCan has contacted us to note that their presentation actually addresses only the geoscience verification plan, as was originally requested by the panel for today. So a quick change back to Plan A, which is we will hear from Natural Resources Canada immediately after CNSC, and then we will go to the panel's questions. With that, I'll ask Dr. Thompson to proceed.
Merci, Madame la Présidente. Bonjour et bonjour, membres de la Commission. Mon nom est Patty Thompson. Je suis la directrice générale de la Direction de l'évaluation et de la protection environnementale et radiologique à la Commission canadienne de sûreté nucléaire. With me today are Ms. Kay Klassen, Senior Project Officer for Licensing of Waste Facilities, Dr. Sun Nguyen, Geoscience Technical Specialist, and Ms. Kaiser Francis, the Environmental Assessment Specialist on this project. CNSC staff have reviewed OPG's submission of the updated geoscientific verification plan. This was requested in Information Request EIS 12511. Staff sufficiency review of this information request can be found on the registry as entry 1867. Today's presentation summarizes CNSC staff's review as presented in PMD 14P1.2. This presentation covers the following points: the purpose of the Geoscientific Verification Plan, or GVP, the main points of Information Request EIS 12511, the main point of OPG's response to that information request, CNSC staff assessment methodology, the results of CNSC staff review with respect to the following GVP activities proposed by OPG: geological characterization, geomechanics and excavation damage, shaft seal performance, other studies in support of the safety case, and trigger criteria. The presentation will also cover the handling of the uncertainties associated with the safety case, CNSC staff conclusions, and CNSC compliance monitoring program to ensure that the GVP would provide the necessary data and information to verify that the DGR system falls within the safety envelope for both pre- and post-closure safety, which forms the licensing basis. To start the presentation, it is useful to review the purpose of OPG's GVP in order to understand its important role in the licensing process. OPG has completed a geoscientific site characterization plan initiated in 2006 to obtain site data on relevant aspects of geology, hydrogeology, geochemistry, geomechanics, and seismicity. 8 boreholes were drilled at the site to characterize the subsurface conditions. The Geoscientific Site Characterization Plan provided reasonable evidence that the rock formations being proposed to host and enclose the DGR would provide multiple barriers to safely contain and isolate the low and intermediate level radioactive waste. However, subsurface characterization was performed from the ground surface and has not been done underground. There remains some uncertainties in relation to the subsurface site conditions and data obtained. In order to reduce the uncertainties, OPG has developed, in accordance with CNSC requirements, a geoscientific verification plan to gather additional information to confirm that the subsurface conditions fall within the safety envelope defined in the safety case. In addition, the activities of the GVP also aim to collect geoscientific data to optimize the DGR design and reduce construction and operational risks. The information from the GVP would also be used to update the safety case in support of future license applications, should the project proceed. OPG submitted a GVP in 2011 in support of the environmental assessment and license application to prepare site and construct the proposed DGR. Information request 12, EIS 12-511 required that the GVP be updated in order to include more details on specific methods, location, timing, sequencing of sampling, and triggers for changes to the design of the proposed DGR and benchmarks for verification of the safety case. OPG's response to information requests, EIS 12-511, contains a GVP that has been updated with respect to the one submitted in 2011. The following main points are provided in the response. A more detailed description of the various verification activities and definition of trigger criteria as requested in the information request. The updated geoscientific verification plan divides the proposed activities into two categories. One, those activities that support the geotechnical design and reduce construction and operational risks. And secondly, those activities that support the long-term safety case. The response and updated geoscientific verification plan address CNSC staff's recommendation number 20, which was found in PMD 13P1.3, and the revised recommendation 19, which was provided to the panel as undertaking number 15. Recommendation number 20 requested that OPG review and, if necessary, revise the long-term geomechanical models and the safety assessment at the end of the shaft construction before lateral development is started. Revised recommendation 19 related to the need for OPG to develop and conduct a research and development program on the longevity of shaft seals. The program should include demonstrations that the long-term seal performance and their interaction with the host and cap rock formations, as well as other formations that influence the long-term safety case. I will now pass the presentation to Dr. Nguyen.
Merci, Madame Thompson. Bonjour, Madame la Présidente et Messieurs les Commissaires. Mon nom est Sun Nguyen. CNSC staff reviewed OPG's response to EIS 12-511 by verifying whether the response is in line with the guidance and requirements set out in IAEA and CNSC safety standards, SSR 5, SSG 23, and G320, respectively. Staff also used technical knowledge and experience to evaluate the rationale and methodologies proposed for geoscientific monitoring activities. This knowledge and experience were gained through staff involvement in projects that have been carried out at underground research laboratories, or URLs, around the world, by conducting independent research and by keeping up to date with technical information through international and Canadian conferences and workshops. CNSC staff also sought clarification on particular aspects of the updated GVP in a teleconference with OPG. The outcomes of that meeting are documented in staff's sufficiency review found on the registry at number 1867. The geoscientific verification activities proposed by OPG are summarized on this slide. They would be initiated during sinking of the shaft at different elevations to characterize a range of rock types. During lateral development, the verification activities would focus on the host Coburg Formation. All of the planned activities would provide data to verify the long-term safety case. The activities shown in the box at the left, in addition to allowing the long-term safety case to be verified, will also provide the data to optimize the DGR design and to ensure safety during construction and operation. The data from the verification activities shown in the left box would be compared to the trigger criteria defined in OPG's response. In the following slides, CNSC staff will summarize OPG's verification activities in more detail and provide CNSC staff's assessment of each of those activities. Geological characterization activities will provide information for both pre- and post-closure safety. During construction of the shaft and lateral developments, OPG proposes to perform geological mapping by direct visual inspection and by analysis of high-resolution digital images and LiDAR images. A seismic reflection survey will be carried out along all emplacement rooms to characterize the configuration of the surface of the Precambrian basement below the DGR and to identify any structural discontinuities that may be present. CNSC staff conclude that the proposed activities will provide a permanent record of rock structure and quality for future safety case updates and also allow for the optimization of the ground support. CNSC staff recommended and OPG have agreed to consider the use of geophysical methods to verify the presence or absence of major fracturing outside of the DGR footprint. This is reported in staff's sufficiency review. In situ stress and upscaling tests will provide information for both pre- and post-closure safety. During construction, OPG proposes to perform lab compression tests on large 160 millimeter diameter samples of the Salina A1, Queenston, Georgian Bay, and Coburg formations. The results will be compared to similar tests that were already performed on 76 millimeter diameter samples in order to assess the effect of scale on mechanical properties. OPG also proposes to measure in situ stress in the Salina A1, Queenston, Georgian Bay, Coburg, and Sherman Fall formations using the USBM method from the US Bureau of Mines. CNSC staff recommended that OPG assess anisotropic and creep properties of the same rock formations where in situ stress will be measured. OPG agreed to carry out this recommendation in the teleconference as reported in staff's sufficiency review. It should also be noted that in the updated GVP, OPG proposed to perform periodic laser profiling in rooms and tunnels. This will provide additional information on any time-dependent movement. Additional geomechanical tests performed underground will further confirm the geomechanical properties and in situ stresses. These tests will be reviewed in the following 3 slides. Excavation response test will provide information for pre- and post-closure safety. During construction and operation, the rock mass response to the excavation of the shaft and lateral openings will be monitored. A LiDAR survey is planned to provide a detailed profile of excavation openings to monitor rock response and provide data for numerical modeling. As an example, the illustration on this slide shows the proposed instrumentation to measure stress and displacement around the shafts at the dolostone limestone horizons. The monitoring results would be used to calibrate geomechanical models in order to verify the geomechanical properties determined in the lab for both small and large samples. Monitoring results would also be used to verify the in situ stress magnitude and orientations measured using the USBM methods previously discussed. Similar types of monitoring are proposed for rooms and access tunnels. CNSC staff conclude that the proposed plan is adequate to provide confirmation of design of excavation and shaft liner, optimization of ground support, verification of geomechanical properties and in situ stress, and calibration of the geomechanical model. Under excavation test, will provide information for both pre- and post-closure safety. In this test, the rock mass response during excavation of a room will be monitored. It is likely that the geoscience room will be used for the test. Instrumentation will be pre-installed in boreholes excavated from the adjacent main level sump. This instrumentation would allow the measurement of the change in deformation and stress in the rock mass during the excavation of the geoscience room. The data recorded during the excavation of the geoscience room could be back calculated using a geomechanical model in order to verify the geomechanical properties and in situ stress determined previously from lab tests and USBM measurements. During the teleconference reported in CNSC staff's sufficiency review, staff recommended that pore pressure be monitored in order to verify the effects of pore fluid on mechanical behavior and also to verify the hydraulic response of the host rock. OPG has concurred with this recommendation. Pillar response tests will provide information for both pre- and post-closure safety. These tests are proposed for 3 pillars, 2 located in panel number 1 and 1 in panel number 2. Instrumentation would be installed from a fully excavated room in order to measure the change in stress, deformation, and the microseismic events during the excavation of an adjacent room. An inspection borehole would also be excavated to obtain cores for lab strength testing and to allow for the visual observation of damage with a televiewer. CNST staff are satisfied that the proposed pillar response tests at 3 locations will provide both a large-scale verification of pillar integrity and a confirmation of geomechanical properties and in situ stress. Excavation damage zones, or EDZ, are important factors that influence the post-closure safety case. The EDZ will be characterized at 8 levels along the main shaft in the Salina F, Salina C, Salina A2, Salina A1, Cabot Head, Queenston, Georgian Bay, and Blue Mountain, and Coburg formations, and also during the lateral development in the Coburg formation. The EDZ characterization will be initiated during construction and will be extended to the operation and decommissioning phases. A series of radial boreholes will be established as illustrated and will be geologically characterized prior to testing and instrumentation using a televiewer. Ultrasonic velocity logging techniques will be used in the geophysical boreholes. Permeability and fluid pressure will be measured and cores will be retrieved from other boreholes. The data from the 3 different sets of boreholes will be correlated in order to characterize the extent and hydromechanical characteristics of the EDZ and its evolution. CNSC staff conclude that the proposed activities will, number 1, provide data on the extent of the EDZ, the mechanical hydraulic characteristics of the EDZ and its evolution. Number 2, provide data for the calibration of geomechanical and hydraulic models. And lastly, verify assumptions of the safety case. The long-term performance of seal materials is another important component of the post-closure safety case. In situ borehole testing of proposed DGR sealing materials would be conducted with a geoscience room in the Coburg formation. The purpose of this study is to support the DGR safety case. The test might be similar to the one performed at the Monterrey Underground Research Laboratory, or URL, in Switzerland, as illustrated on the slide. Saturation, hydraulic conductivity, and long-term chemical compatibility with the saline pore fluid will be monitored. The interface between materials and host rock would also be examined. Similar types of studies are currently being performed at different URLs around the world. CNSC staff are currently involved in those studies through international collaborations. CNSC staff will use that experience in order to review the detailed design of the seal performance study to be developed by OPG should the project be approved. These studies would be initiated during construction and would be extended to the operation phase of the DGR and beyond if necessary. It is likely that more than one vertical borehole test would be installed in order to allow sampling at various times. Similar types of demonstrations are also proposed for the Queenston and Georgian Bay Formation by installing horizontal boreholes from the shaft or vertical boreholes in large blocks or vertical boreholes at other surface sites. CNSC staff are satisfied that the proposed studies will provide additional confidence in the longevity of shaft seals. These studies also fulfill CNSC staff revised recommendation number 19 in undertaking 15, which was submitted during the hearings in the fall of 2013. As part of the GVP, OPG proposes to conduct during construction and operation additional studies in support of the post-closure safety case. The first study relates to fracture infill minerals. Fracture infill minerals would be collected in the Coburg, Sherman Fall, and Kirkfield formations in order to verify the geochemical characteristics and ages of mineral infill. Geochemical information on mineral infill is required to confirm the pore water profiles that support the conclusion in OPG's EIS that at the depth of the proposed repository, the surrounding rock formations have remained isolated for geologically long times of the orders of hundreds of millions of years. The age of minerals that fill fractures would provide important information on timing of any fluid flow that could impact the integrity of the repository. In the second study, long-term in situ diffusion tests would be conducted in the Coburg Formation to verify estimated rock matrix diffusion coefficients. A third study looks at multi-phase flow processes. Water and gas injection testing in 20-meter long boreholes is planned for the Coburg Formation to verify multi-phase flow and transport properties and mechanisms. A fourth study would be undertaken to characterize microbial activity in the Coburg Formation and its influence on DGR performance, and to evaluate the occurrence and post-closure effects that microorganisms would have on geochemistry and gas generation within the DGR. In the fifth study, seepage water will be collected where possible from the Coburg, Sherman Fall, and Kirkfield formations to provide information on the groundwater geochemistry. CNSC staff are satisfied that the above studies would provide multiple lines of evidence in support of the ability of the geosphere to provide long-term containment and isolation of the waste. Preliminary trigger criteria for design updates for pre-closure safety and benchmarks for the post-closure safety case are defined, as well as the ensuing course of action should those be exceeded. Trigger criteria and contingency measures, should those criteria be exceeded, are given in detail in OPG response to information request EIS 12511. It should be noted that the purpose of those criteria and contingency measures is to ensure pre-closure safety. As an example, there are uncertainties related to the magnitude and orientation of the in situ stress, since those parameters are difficult to measure from the surface. In order to handle the above uncertainties, OPG has provided a design based on two conservative assumptions. Number one, the long-term strength of the host rock is equal to the crack initiation stress, which is approximately equal to 40% of the lab peak strength. Number two, the maximum horizontal stress is assumed to be equal to 2 times the overburden stress. This value corresponds to upper bound values based on regional data. In addition, OPG assumed that the maximum horizontal stress acts in all directions around the lateral openings. In addition to the above conservative assumptions, for increased confidence in the stability of the underground openings, OPG has proposed trigger criteria for the magnitude and orientation of the in situ stress. should the magnitude of the measured maximum horizontal stress exceed 34 megapascal, which is equal to the above upper bound value of the maximum horizontal stress, or the direction of that stress deviates from plus or minus 40 degrees from the estimated northeast direction, the orientation of the rooms and the measures for ground control would be modified if necessary after a re-evaluation of the room stability. From CNSC's staff experience, similar adaptive management methods have been used with success at underground uranium mining facilities in Saskatchewan under much more challenging conditions than the ones expected at the proposed DGR. If safety is not maintained, CNSC staff can issue an order to stop unsafe activities. The order would then be reviewed by the Commission. Benchmarks for long-term post-closure safety are more difficult to define using quantitative criteria. Post-closure safety relies on multiple barriers and characteristics, and it is difficult to define criteria for each individual component of the system. However, for the proposed DGR, important characteristics could be identified as follows. The low permeability of the host and cap rocks that would ensure that diffusion would dominate transport of contaminants, which will be at very slow rates. Number two, the absence of major fractures that ensure there will be no preferential transport pathways. Number three, the absence of economically viable resources that would minimize the likelihood of future inadvertent human intrusion. If the GVP shows deviations from one of the above characteristics, this deviation would be reported to the Commission in an initial event report. CNSC staff would review that assessment. If staff finds that, number one, long-term safety could not be ensured even with mitigative measures, or number two, a major change in the design of the DGR is needed, staff will bring the matter to the Commission with a recommendation to either abort the project in the first situation or amend the license in the second. As a result of staff evaluation, CNSC staff are satisfied with the identification and definition of the trigger criteria and benchmarks and ensuing courses of action. As previously discussed, an important objective of a GVP is to reduce uncertainties associated with the post-closure safety case, and it is useful to review the way uncertainties are handled by OPG. Uncertainties related to the natural and engineered barriers always exist due to the long time frame, the complexity of the processes, and the variability in characteristics of the DGR system. Uncertainties do not necessarily mean that a project should be aborted unless those uncertainties compromise the licensing basis or safety of the project. A DGR project usually proceeds by stages: construction, operation, decommissioning, and post-closure. In Canada, the regulatory licensing process coincides with the stages of DGR development and involves a full review in a public process. To justify the decision to proceed with the next stage of development, international and Canadian guidance requires the proponent to submit a post-closure safety case that first identify the uncertainties and second, show that they do not influence safety. OPG has applied for a site preparation and construction license that would not allow any waste to be emplaced. The uncertainties associated with construction and operational risks have been adequately identified and handled with the definition of trigger criteria based on the geotechnical verification activities. CNSC staff have also found that with respect to the long-term or post-closure safety, OPG has adequately identified the uncertainties. OPG has bounded the uncertainties with a large degree of conservatism and are shown that they are irrelevant to safety, and OPG has adequately shown that the uncertainties do not impact long-term safety. At this time, OPG's updated GVP conforms to international best practices and will provide the basis for any design modification to ensure safety during construction operation and reduce the uncertainties related to long-term safety. CNSC staff have assessed OPG's response to information requests, EIS 12-511, and the updated GVP attached to that response. CNSC staff conclude that OPG has adequately planned the verification activities that are needed to achieve the objective of the GVP. The verification activities would address or reduce uncertainties associated with geoscientific aspects of the DGR and the DGR safety case. The information provided in OPG response and the updated GVP also allowed CNSC staff to conclude that the response to recommendation number 19 in PMD 13-P1.3 and the revised response to recommendation number 20 in undertaking 15 have been adequately captured in the updated GVP, and those recommendations are no longer needed. If the DGR is licensed to proceed, CNSC staff will, as part of the compliance verification program, verify the acceptability of the detailed test plan for each verification activity of the updated GVP, monitor the licensee's implementation of the GVP throughout the construction phase, and verify that the repository design adequately takes into account the results of the GVP activities to ensure pre-closure safety. The GVP will provide data that CNSC staff can use to verify against the bounds of the post-closure safety case. Through independent research, CNSC staff have developed a set of modeling tools that can be used to interpret the GVP data and to verify that the observed properties and performance of the DGR system fall within the safety envelope, also called the licensing basis. Merci Madame la Présidente et Messieurs les commissaires pour votre attention. Je passe maintenant la parole à Madame Thompson.
Thank you. Thank you, and Madam Chair, this completes CNSC staff's presentation. We're available to answer questions.
Thank you very much.